Good morning, my dear students. In the previous video presentation, we have discussed all the problems from exercise 1.1 of class 9 of State Board. Now we'll discuss some more concepts related to set theory, and we'll try to do some problems from exercise 1.2 from the same textbook. First concept which we are going to see is set having finitely many elements. Finitely many elements is called a finite set. It's called a finite set. Example, set of all people in your house. Maybe at the maximum you may have 10 people. Depends upon your father, mother, brother, sister, everything. You can write the names also if you want. It will give you a finite number. Therefore, it's an example of finite set. Set which is not finite is called an infinite set, or set which is not finite, or having infinitely many elements. Is called an infinite set. We call it as infinite set. Example, set of natural numbers. There are infinitely many elements. Starting from 1, 2, 3, 4, etc. It goes up to infinity. Okay, set having only one element. Is called, there is a special name for that, a singleton set. In fact, set of all capitals of India, capital cities of India. There is only one capital city. There is only one. The answer is New Delhi. Okay. Then set of all numbers between 5 and 7 in the set of natural numbers. There is only one natural number between 5 and 7. It is only 6. It's an example of singleton set. Okay. Then set having no element. Set having no element is called set having no element. Okay, having no element is called a null set or empty set, or there are different names for the same. Void set, denoted as, we call it as phi. The symbol is used, phi. Or set braces without writing anything in between them. Don't write anything in between the set braces. Okay. Now for set having no element is called an empty set. Set of all natural numbers between 5 and 6. It's a simple example. Okay, having set of all natural numbers between 5 and 6. There is no 5, 6 are two consecutive natural numbers. There is no natural number between 5 and 6. Okay. Set of all people who are having 3 eyes in the world. There are only 2 eyes for every person, any person in this world. For having 3 eyes, so is an empty set. Okay, number which we get 7 when you throw a die. When you're going to throw a die, 7 is not at all possible. We can get only at the maximum 1, 2, 3, 4, 5, 6. When you throw a die, we'll get only 6 numbers, 1, 2, 3, 4, 5, 6. Okay. Set when we have a number greater than 6, when you throw a die, it's an empty set. Okay, greater than 6 we can say simply, instead of simply saying 7, we can say even greater than 6. I repeat, set of numbers while we have greater than 6, while you throw a die, is an empty set. Okay, these are all examples and then definitions and examples. Then 2 sets, capital A, capital B, have the same set of elements, same elements. They are said to be equal sets. See here, A is equal to, let us say, 4, 5, 6. Okay. B is, let us say, 16 by 4. It's again 4 plus root of 25. Even if I don't write plus, it means only plus. Then cube root of 216. I get the same set of values. For order doesn't matter. We already know. Okay, order doesn't matter at all. Order can be anything. You can write in any order. Okay, 16 by 4 is again 4. Root 25. Of course, plus is understood. We need not write anyway. It is 5. Cube root of 216 is again 6. They both are equal. We write it as A. We write A is equal to B here. Here A is equal to B. If A and B are not equal, we use the symbol A not equal to B. If they are not equal or don't see the same example, you will get confused. See, if C not equal to D, we write like this. This is how you write. Okay, two sets having same number of elements, they are said to be equivalent sets. Okay, number of elements in general is called cardinality. Cardinality of a set. Cardinality of a set A is denoted as n of A. Okay, for two finite sets, it should be finite, it's very important. Two finite sets A comma B, if n of A is equal to n of B, we say that A comma B are equivalent. They are said to be equivalent sets. The notation here is, this is how you use. This is how you use similarity of triangles. You might have seen. Maybe in 10th you may get it. Okay, the same symbol is used. Okay, they have cardinalities are equal for two finite sets. They are said to be equivalent. Okay, actually any pair of equal sets will also be a pair of equivalent sets, because the element themselves will be the same. The element themselves will be the same. Therefore, automatically the number of elements will also be the same. Therefore, pair of equal sets will be a pair of equivalent sets. But pair of equivalent sets need not be a pair of equal sets. I will give you an example. Okay, A has elements A, B, C. Capital A has elements A, comma B, comma C. Capital B has elements 1, comma 2, comma 3. Now n of A is equal to n of B is equal to 3. Therefore, here I mean to say A is equivalent to B, but A not equal to B. If A and B are equal, they will be equivalent also. Pair of equal sets will be a pair of equivalent set. But the converse is not true. This is an example. Here A, B are equivalent, but they are not equal. They are not equal. They need not be equal. But random, if we tell somebody to give two examples of two sets, both of them may give equal sets and equivalent sets, but at the same time they may be equivalent also. Okay, therefore that is the reason why we say need not be equal. Pair of equivalent sets need not be equal sets. Need not be equal sets. Okay, then if each and every element of is also element of A is also an element of B, we say that A is a subset of B. A is a subset of B. You mean to say the symbol is this way. Okay, example, let me give an example. A has elements A, B, C. Then B has elements A, B, C, D. Here A is a subset of B. Here A is a subset of B, but A not equal to B. Then we use the symbol, you use the symbol A is a subset of B. The equality is taken out. Okay, equal sets are also subsets to each other. There will be a set is a subset of itself. Such a kind of subset is called improper subset. Every set is considered to be a subset of itself. Such a set is called an improper subset. And null set is considered to be a subset of every set. Null set is considered to be a subset of every set. These two things you are supposed to remember. And the another way of saying the same thing is A not equal to B. Instead of saying A not equal to B, I mean to say if every element of A is also an element of B, and there exists at least one element B in B which is not there in A. Such a set is called proper subset. Here ABC or here ABC or here. There is one more element D which is not in B which is not in A. Therefore here we mean to say A is a proper subset of B. Okay, A is a proper subset. A is contained in B or B contains A. Either way you can say. A is contained in B. B contains A. Either way you can say. Either way you can say. It is always easier to follow. Then one more thing. If in a particular situation, the biggest set containing all the possible sets subset in the given situation is called universal set. For example, if I am going to think about competition held between students in a particular school, okay, universal set can be set of all students in that school, or set of all students of in that particular district you can consider, or the city you can consider. Therefore, universal set is your own option. If I am going to think about some operations between the number theory, and okay, an universal set can be set of natural number, or set of whole numbers, or set of integers. Depends upon the situation you can define the universal set. We denote this as U, universal set U, or this symbol is called epsilon. Both the symbols are used for universal set. Okay, if I am going to be given U, let us say 1, 2, 3, 4, okay, and A, a subset of it, let us say 1, 2, by A dash, or A complement, we call it as complement. Okay, complement of A, we mean A dash is equal to 3, 4. All the elements in U other than the elements of A is called its complement. For A dash has element 3, 4. Okay, if you are given a set A, okay, and set of all subsets of A, the set containing all the subsets of A is called power set of A. We call it as power set. It is called power set of A. It is called power set of A. For example, if I am going to think about A is equal to, let us say 1, then P of A will be, empty set is a subset of every set, and set containing 1. This is the power set. Okay, then we can derive a formula for number of elements in a power set. I will list out for you, I'll list it out for you. Just listen how we go about it. Okay, I'll make it as a tabular column and do A, then N of A, then P of A, N of P of A. Let us just try. Okay, it is empty set. Number of elements here is 0. P of A will be set containing empty set. It is 1. Can be written as 2 power 0. Okay, let me think about simply A. There is one element. Here empty set containing A. There are 2 elements, can be written as 2 power 1. Thirdly, let me think about A comma B. Let us say there are 2 elements, empty set containing A, set containing B, set containing A and B. There are 4 elements, can be written as 2 square. Then let me think about A, B, C. Let us say there are 3 elements, empty set containing A, set containing B, set containing C, set containing A comma B, set containing B comma C, set containing A comma C, set containing all the 3 A comma B comma C. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements. Therefore, in general, we can have a generalization. If N of A is equal to M, M is finite. It should be finite. Okay, then N of P of A to be always 2 power M. Let me explain once again. I take an A as empty set. Number of elements here is 0. How do you think about power set containing all the subsets? Empty set is contained here. There is one element, 2 power 0. There is only one element here. Empty set containing A. There are 2 elements. Can be written as 2 power 1. There are 2 elements here. Empty set containing A, set containing B, set containing A and B. There are 4 elements, 2 square. Empty set containing A, B. C, A and B, B and C, C and A, and A, B, C. There are 8 elements, 2 cube. Now, in general, if there are m elements in a set A, the number of elements, the power set will be 2 power m elements. 2 power m elements. These are the basic concepts you are supposed to remember. We'll just do at least one problem from exercise 1.2. Okay, we'll do just one problem from exercise 1.2. Just see here what is given. Let us just check with what is the first problem. Okay, we'll check the first problem in exercise 1.2. Okay, what is given? Find the cardinal number, cardinality, cardinal number, everything is the same. Okay, find the cardinal number. Okay, that is the first sum in that exercise 1.2. Exercise 1.2, what is the first sum? Let us see. Okay, just see here 1.2. Let me write the question quickly. Okay, first sum, first subdivision. He says cardinal number means how many elements are there. I am supposed to write. Okay, just see here m is equal to p q r s t u. P, comma Q, comma R, comma S, comma T, comma U. Now for n of m, here is 1, 2, 3, 4, 5, 6. There are 6 elements here. Okay, then subdivision 2. P is equal to x z. X is equal to 3n plus 2. N element of W. X less than 15. Okay, see here, how do you list? You have to list the element, then only you will be able to find out. N is 0 means 2. Then 1 means 5, then 2 means 8. There is an increment of I think an increment of 3 everywhere. 3 plus 2, 3 2s are 6, 6 plus 2 8, 9 plus 2 11. Then of course 12 plus 2 14. X is less than 15 given. How many elements there? For n of p is supposed to be here 5. There are 5 elements here. Unless you are able to list out, you won't be able to identify the number of elements there. Then q is equal to y is such that y is equal to 4 by 3n. N element of n, and of course he means to say 2 less than n less than or equal to 5. That is what is given. Okay, you see here n is 1. Therefore, I mean to say when n is 1, it is 4 by 3. Okay. Will I get 4 by 3? 4 by 3 is less than 2. Therefore, it is ruled out. Let me rule out. Okay, it is ruled out. Okay, then 4 by how much I am getting? You mean to say 4 by 2 2s are 4 by 6. Here it is getting reduced. Therefore, it is an empty set automatically. Okay, it will be an empty set automatically. Even for n is 1, I mean to say, here it is the n, there is no x here. One second, I'll just check the question once again. 2 less than n less than or equal to 5. Only from, sorry, it is not an empty set. I'll explain once again. Okay, it is between 2 and 5 inclusive 5. Okay, sorry. Therefore, I mean to say here 4 by 3 3s are 9. Then 4 by 16. Then of course 4 by 20. 4 by 20 is nothing but 1 by 5. These are the 3 elements. 4 by 9, 4 by 16, 4 by 20. Sorry, I made a mistake. It's not an empty set. I repeat once again. When n equal to 3, it is 3 3s are 9. N equal to 4, it is 3 4s are 12. Sorry, it is 3 4s are 12. Then 15. Sorry, 3 4s are 12. Then 3 5s are 15. Here you can write it as 1 by 3. I repeat, when n equal to 3, it will be 4 by 9. When n equal to 4, it is 4 by 12. When n equal to 5, it is 4 by 15. These are the 4. I am supposed to write the number of elements anyway. N of q here is 3 anyway. N of q here is 3. N of q here is 3. You please check once again. Then next one, x is an integer between -5 and 5. Okay, x is an integer. See here, fourth one. Let me rub it off and do if you want. Let me just rub it off. Let me just rub it off and write. He means. Sorry, it got disconnected. We'll continue from the next subdivision in the next video. Thank you.